Hello, hello, hello. I have a very bright ceiling, which makes my head really bright as well. Ooh. Don't know if there's anything I can do about that. Another day, another stream. Just gonna continue what we were doing yesterday. There's one thing that I was thinking about since yesterday. And it was around comparing those bits. And I was looking at the at this here, and there is quite a few things there where it's like you want to compare the most significant bits. There's not that many. There's 1, 2, 3, 4, 5. And I was actually thinking, instead of like masking the ones that I don't want, which is one operation, then comparing with another number, I was wondering if I could bit shift this one by 4, right? So I could just basically say move these by 4 to the right, and then compare the value with the value that's on the right. It will also make the compared thing a little bit smaller. And that also let me parameterize all of those things. So I could easily say, if I want to read 3 on the left, I know that I need to move them by 5 to the right. So I think I'm going to start with that, and then see what I can get from that. And also I can make it something, I can make it like not a function. I can make it a define, which could be quite interesting. If I put it here, right? Define, I'm putting it, well, it's going to be like an internal one, so it doesn't matter. Define has first n bits, and I can say a value x, a number of bits followed by a value to check against, right? And this would be x bit shifted to the right by 8 minus the n, and then I can just say is equal to v, right? This would be my comparison. So in the case of like I want to compare the first 4, then I would say x, which is going to be the value, bit shifted by 4, 8 minus 4, and then I compared stuff. So I think this is not a terrible thing to do. And in here, this is kind of what I was doing there. I was checking the first bit. This one's interesting because I'm actually just building this, but in another way, if we want. So in here, I should be able to replace this with has first n bits. Actually, it has first bits. I'm going to move the n. Has first bits, and then this is going to be item data at 0. How many do I want to check for? And what's the value that I want to check for those 4? 0, x, 8. And this, in theory, should expand to bit shift to the right by 4 is equal to 0x8, which is a bunch of zeros. So there's like something that can be read. Slightly understandable. The only thing is like you can't really, I don't know if you can document as well macros, but I think that's pretty good. And this one is going to do the same thing. So it's checking has first bits data, item data at 0, and then this is going to be I'll look at 4 of them, and then it's going to be 0, x, 9, right? It's going to be, I wonder if I should just get the first 4 bits instead of that, because when I go here, for example, I'm not going to get a clear Actually, this one is a clear value if I just use, yeah, it's always going to be a clear value actually. Not in hex, actually also in hex. Because this one says A or B because you can go between those two. But when I do this, right, and I say bin to hex, and I put it there, it's going to give me 5. So I know I can just say 5. Which should be quite easy. And that should, in theory, let me define MP, and then I can just say, what could I call it? First byte. If this was a struct and I was using like a value to differentiate what the union is, it would be a discriminated union. So maybe discriminator is really long. Like if I call it discriminator, that's a really long name. Maybe disc. I don't like the. And then this one's going to be int. We're going to start with int, for example, and that's going to be 0, right? And then I can do map, which is going to be this, which is 1, 2, 4, 8, and then array is 9, and then string is 5. I thought this one was 5. No, this one's not 5. That one is 5 plus 2, 7. String is 5, and then yeah, I need to make sure. So this is 5 for sure. Actually, array, yeah, array is 9. But like 5, if I add 1 is 6, and I add 1 is 7. So yeah, for sure. So uint that's where I probably should put uint there and an int. But this one specifically says negative fixed int rather than unsigned. So I'm not sure exactly what to do with like negative fixed int. I might just do int and then neg int because I probably want to do it that way. So that's not that bad. And then here, then I can say MP discriminator for map and MP discriminator for array and MP disc for int, and this is going to become has first bits, this one, and I just want to compare 1 bit to this. There you go. So there's a lot of like has first bits, has first bits, has first bits, which I might be able to put in a thing that loops basically. And string is going to be the same thing. String is string actually 111? So 111 is 7. So did I do the wrong thing here for strings? Negative fixed int 111. Well, strings is supposed to 101. Oh, I'm masking the first one. Okay, and this is 5 in. Like this is the 5 at that position. So here I should be able to recreate it as has first bits item data at 0, and then go 3 and MP disk string. So these are actually all my fixed things, and I could technically just say the same thing with like has first bits and then say 8 and then give it a full number, and I feel like if I do that it would give me 8 minus 8, so it's going to shift to 0, so the compiler should be able to eliminate that. So I might do that as well. Now if I do that, I'm going to start going into something I wanted to do, which was define MP type discriminators, which is going to be a what am I going to do? It's going to be a kind of a value. So first is going to be how many bits I need to read. Actually, I can't do that because there's a different logic in there. Okay, let's just ignore that. I really wanted to just normalize all of this, but I'm not going to do that. So here, what is this? I'm just reading this many bits. Sure, and then nil and stuff like that. Okay. So one thing that I was thinking about yesterday, I did +1 because this is containers don't have fixed length. And this is basically saying the length of the container is something like that. But in reality, if I do item next minus item data, this gives me the header size. Simple as. And I know I used header size somewhere else here, which I set to 1, but actually here I can say item next minus item data. That gives me the header size. And that I should be in the same position now. Things still work. It did recompile as well, yeah. So things are still working. So I didn't do anything here, right? Okay, so next I'm going to stay on. I wanted to move stuff to another file to start cleaning it up, but I'm going to stay in this file for now. Let's create a test. Okay, let's move stuff around then. If I'm going to start doing test, let's move stuff around. I think it's going to be easier. Do I have a what do I have here? I have got message. I got the H and the okay. So great. So I'm going to move all of these. All of these to MessagePack.h. Okay. And this sure and this sure. Right. Now when I come back here, I should be able to go include MessagePack.h. Right, so that should be better. And then I'm probably going to want to keep these. I'm going to keep these in the C file, not in the H file, because I don't really need them in the other one. So then I'm going to move all of these, and then it's going to automatically tell me which for declaration I'm missing when I move all of these across. Because I can just delete this, go to MessagePack.c and paste it right there. Delete this and include MessagePack.h. Right, so I should have maybe a few things that are missing. Exit. Now that exit is not great. I should probably have my init return some kind of error. So I'm gonna get started on that. Just make it a bit. This is gonna be a little bit more tidy in terms of work. And next, I'm gonna have define MP results x MP OK. And then I'm gonna have MP error with no extra details, right? MP results, and then from there I can create a enum MP result right here, which is going to have basically this, and instead of MP type it's going to be MP results. Okay. Redefinition of enumerator x. Am I missing something? I guess I don't really have a value here. One thing I would want to make sure is that OK is 0, but if I keep it in this order, it will just happen anyways. Unused declaration of value. Yeah, I don't need value, that's why. Okay, so now I've got results. And I'm also going to have, yeah, so that's just fine. MP is container type, could be used somewhere else. I might put this one lowercase so that maybe it can be used by whoever uses this. But now I should be able to go to, well actually I'm going to go back to here and start by saying you're going to get an enum MP result, which here you're going to say return MP result. Okay, actually I'm going to put MP OK. This should be simple enough. And return MP OK. And this one is actually error. And just to round everything up, I am going to add a no, I'm not going to add one. All the information should be in the, actually this contains a type in there. I'm going to leave it like that. I think that's fine. It's not fine, but I'll just keep it at that. And this is going to have a enum MP result, which I can return MP error. And return this. That's why you're in it. And next is just true and false, which is correct. malloc is okay. mcpy is okay. I was actually thinking about instead of doing this, have something that just returns the length, just like write to a buffer that's provided and just return the length. I'll keep it like that for now. Okay, so I should still have one error there, which is this doesn't match the signature, which I can fix quite easily. And then now I can go back to main inside MessagePack, and I should have a bunch of stuff like init, str type, and read string. So I can go to MessagePack.c, and I can start going down. So I'm going to need init. I don't know if I'm going to need this one, but I might as well just grab it as well. Don't remember if I had this one, but might as well grab it. Next. Okay, read string. Just doing this little dance there that just collects a bunch of those. There you go. And I can just paste it here. This is where like this type of action of like going at the end and editing a bunch of stuff, I'm not super familiar with. So I can do it for these, for declaration, main message pack. So str type there, mp str type, undeclared function. Pretty sure I added it there. I didn't. That's because it was right there. Which it probably shouldn't really. Should probably put it after my okay. Right, just a little bit of organization. Okay. I should probably have like a result type as well. Let's just do that quickly. str result, and instead of type you get a result, and this should not have a value, and results is like this. Now I can yank this and go back to the other file and paste it right there. Right, now the main there is going to be quite a bit, oh, it says it's redefined, interestingly enough. Yeah, because it thinks I'm using it. I'm not in the right main here. This is the main that I want. Now this main is going to be a little bit smaller now. Obviously I'm still browsing stuff quite a bit. So I'm going to start setting up actual tests that I want to keep. Static void test empty array. Actually, what I really want to, I just want to test types to start with. So what I want to do is test. I'm going to start with the. I'm not going to do the binary one just yet. I want to do a uint8. Right, and if I think about it, uint8, I should be able to scroll down there and see. Oh, it's actually not showing it to me. It's going to be in the int family, isn't it? Yeah. So uint8 reads 1 extra, and this is unsigned. What about int8 signed? So I just need to cast it to a different thing if I'm reading a value. So these should be quite nice to play with. So I'm going to start with uint8. I'm going to say uint8. And what this is going to do is it's going to do a lot of the initial stuff. Right. And I'm going to do there and go uint8. And then the thing is, how do I just generate something that is unsigned? Because if I just do like 56, I'm going to get 38 there, obviously, but I need to go to something that is bigger than 127, so 129. Now I get CC, which is CC correct. But like, do I know it's, you know, do I know that this is like that? I don't know. Let's make a data for that. Echo and paste pipe into xxd rps data slash uint8.bin. I'm gonna start calling them bin. I want to call them bin. Okay, if I do this, then I should do something like this. Assert mp type with int. This is where I'm almost tempted to just introduce the different variations without the fix, because I think that's like being able to say this is specifically a uint8 or whatever would be more interesting than otherwise. I know this is supposed to be compatible with JSON, and then JSON wouldn't have that. But if I ever use a program that actually sends me correct things, then I'd be stuck. Let's start with that and see where we go. Now this test uint8 should fail. I am not. I'm actually not adding. Oh, I'm building lib MessagePack with MessagePack.c, and when I'm running the test, I am building the thing. Okay, so so you can't find all of these. I'm doing lib l MessagePack with l bin, and there is lib MessagePack in there, but I guess it didn't rebuild it. That's going to be the problem. Yeah, that's something we'll have to deal with. I was just looking around and I saw that I've got this old phone, and I put it in my hands and I was like, wow, I really like that phone when I was using it like all the time, because it's so much. It's like a really wide one. It's like a Sony Xperia. It's really wide, and it just holds in your hand so much better. The fingerprint sensor is like right where your thumb is automatically, and browsing stuff is so good. You can go on a website, and there could be a banner at the top that says, we use cookies, or at the bottom plus another thing on top, and you still have like a lot of size in the middle. But this is wiped and stuff. But actually, I think that it would be interesting to see if we could just like run stuff on like devices like that. You can make them like IP cameras. You can make them like, you can do a bunch of stuff. Like there's still a camera, battery, and then if you trim down like all the services, if you like remove all the services, like notifications, like, and optimize the thing and just have one program that runs on it, it can run for fucking ages. I also wonder like if I can root it, then we can just run just like raw like C programs and stuff like that. We might not be able to access the cameras and things like that, but it could be interesting as some kind of controller for connected devices. I'm thinking a USB-C hub, right? You get a USB-C dongle you can plug in USB. It should actually show up as a USB device. And if you're on the other side, you've got a USB to serial adapter, then you can actually start communicating with programs. So you could have a program on the device that actually forwards or like routes messaging on like hardware physical devices, which could be quite interesting. You could even just use like radio messaging for it. But anyways, unknown type CC is interesting. Why did you do CC? Do I just print the byte? I think I print the byte. I am getting a malloc thing, so it's because I don't free at the end. And the thing is, if I do the assert there, it's going to do an early exit, so it's not going to free the value. So I would need to like free it right here. Right, unknown type CC didn't return successfully. Great. So that means now I can read the CC file. So one thing that I'm gonna have a problem with is that every time I'm going to change the H file or the C file for MessagePack, it is going to cause an issue because it's not going to rerun make to just regenerate this file. Even if this file here is it's not a dependency of this. Maybe that's all I need. Could I just say you're dependent on MSGPack as a target? And now if I touch msgpack.c, make test. Oh yeah, it regenerated the thing. Okay, so that's all I needed. That's good. Okay. Right, so now I can go into this file and go into the big branching logic there, and then say I'm going to remove this because it messes up my formatting. Do I want to keep all of the ints together, or do I want to keep all of the variation? I think I'm going to do all variations together first. So here I can say else if item data 0 is specifically 0xcc, which I know this is the one that I want to check, but this is where I may want to do this. I'm going to start doing uint 8 0xcc, because that way I can just use uint a mp disk uint 8. So if it's uint 8, I kind of want the same thing as this, except, and this is where it gets a bit tricky, my size is going to be 2, because I know I've got one that I'm reading, and then one that's in there, and my header is going to be, it's the data starts at data plus 1, and not even that, because the actual, so I'm a bit confused because the value was in there and the value is not in there, so that means it's going to be plus 2. So in reality it's wait, no, the data is in plus 1, that's where it is. Okay, and then reading the value is going to be is where it's going to be a bit difficult, because this is where I need to figure out, is read int always gonna like go, oh, what's the maximum value? It could be because uint 64 is uint 64. So I could just say that, yeah, I think I'm just gonna do that. Type int and do that. I do need something that's gonna let me know where I need to read it, because when I do read int right now, I do this because I know that this, like, what type it is. Here, unless I look at the size, which to be honest could be a good indicator, but it's not ideal. Like, I could basically say, oh, if the size of the type int, like if I got an item of type int and its size is 2, then I should know that, well, there's one byte that's dedicated for like the discriminator kind of byte, and there's one extra, so I should know that it's a uint 8. Which I don't know if this is, I think I'm gonna go with that and then see if there's anything that could change it, because as far as I can tell from the spec, the only thing that changes is there's always a one-to-one relationship between what's on the first byte and then how many bytes after that you read. There's no other way, there's no difference in like, you're the same size, but depending on this one, you need to read it differently. They always have like a different size. So I think that's what I'm going to do. Okay, so at that point, what we're going to do is run make test, and it should do nothing, but I should also make it fail, because the value that I put in my test binary is 129, and I keep losing myself in my workspaces there. My test is here, and what I should do here is to say if I should read the things first, uint 32t value, and mp read int root, give it the reference as well, and not the reference, the address of, if value is different from 129, then I should do like a printf wrong. I'll tidy up those things and then exit 1 to be super explicit, right? And this is going to do something interesting, is that this is not even going to go there, or actually it's going to go there, but that's going to be set to 0 or whatever value I've set. Oh, actually, I don't want to, as a side effect of seeing some garbage memory, this, actually no, this is going to have the int, so it's going to be correct, but I'm not going to get 129. Before we run it, let's just think about what value should we expect here, right? So I have a CC in here, and that's going to be in hexadecimal to binary, is going to be this, right? And the spec says in here you read the 7 bits. So if I remove the first one here, if I grab this and do binary to decimal and remove that first one, I get 76. So in wrong, I'm going to add the value that I got and say value, and I should see 76. wrong 10. Now that's not correct. Unless I'm reading something else. I got a 129. I want to understand why I got it wrong. Because when I read the in there, I'm getting the data, which really should not even be data. It should be next, because that's just what it is. But and then I'm moving 1 by 7 and cancelling that one, and that's the uint32 I'm getting. And data at that stage there is going to be cc, right? So let me just say printf %x, and I'm going to print item data at 0, just for the sake of it. But I know it's going to be cc because I just did something. Now a is a surprising answer. CC 81, and when I read it I'm getting A. Item data, I'm reading this value, I'm giving it this buffer in init. Let's see what init does here. Init's going to come here. It's going to say items count is 1. I don't know what sets items count to 1. That's a bit odd to start with. I just set the data simply, and then if it is uint8, I set it to uint8, set the size to 2, set the next to item data plus 1. So item at data should be the first. Checking I'm not modifying anything here. I think I could just technically fix it, because I know what to do to make it work, but I don't want to do that. I want to know what I've got wrong there. I am definitely still reading the buffer. Okay, that would make sense. Yeah, I just have this problem then, that in my assert I'm not doing some cleanup, so obviously that's going to be wrong. So I'm going to do something a little bit stupid, but not really. Actually, I can't really do that. Let's just accept the fact that I'm causing some issues. Okay, so I've got CC here, so at least now our value is correct. I only got one CC though, so I got CC and I got it wrong. Okay, so I got CC and then 76. Now let's see if I did 0x CC and I did end 1 moved all the way to the end, and I negate that because I want to do that. So that's why I want to printf. I forgot this here. Let's see. I get 76 as well. So I think I'm just doing something wrong. So unless it's because it's a uint and not an int, and uint does something that I'm just not understanding, in which case it would be correct. If I was to, what if I was to cast it to a int 32t? I still get that. Let me try again. Decimal, no. Hexadecimal to binary. CC. is this binary to decimal 204. Oh yeah, that's normal, 204, yeah, that's correct. And then we're basically saying that we're only reading those so if I set this one to 0, 76. Oh, this is what I was expecting. Okay, I'll just okay, so this is correct in that it is wrong, but that's kind of what I wanted. Let me see, I'm still printing CC somewhere. Here. Okay, so this is where we're going to need to do some if. So if item size is 1, then I know that this is what we want, right? Else if item size, and this is very much looking like a switch case, case 1, this followed by break. Okay. Case 2, value is going to be as simple as uint32t item next and 0, because you just read the first byte and then you're good to go. This is also where I kind of want to do next, just to be consistent, and then don't forget to break. Now I would like to do the rest, like the variants, because I'm doing them, so I could just like add them and say, let's look at it. I've just done this one. This one should be easy to do, right? It's going to be, the first half is the same, and I just need to shift stuff by 8 and slap it in there, and it should be easy. But for this iteration, I'd like to try to do a pass on my test, technically like a pass, like echo dollar is going to be 0, great. And then I want to make it fail and then fix it that way. So I want to do like a kind of like a, almost like a test driven kind of thing. Now, uint16, the max of a uint16 is going to be 16 to the power 16, right, minus 1. So this is kind of like the number that I want. So if I grab this number and I just encode it here and I just add 1, we can see how it changes from taking 3 bytes to 5 bytes. So I should probably, well actually what I need to do first is the max of uint8. So I need to have a value uint16, but this is good to test. So I'm going to do this, and I'm going to say echo n, and I'm going to put in there xxd rps pipe data slash uint32 dot bin. And then I want to do the same thing for a 16, which is going to be basically the max of uint8 is going to be 255 or something. So if I just do a gentle 124 just to play with, this is the value that I want. And I can just remove these, put it there, and then call this one 16. Right. Because what I want there is I want to see in my kind of like main file here, which is technically a test suite, if there's a pattern here that can emerge, I can then maybe make like some defines or some functions, so I don't have to retype like read this file, do this. You know, I could have a thing that just check type of what's in the file. For now, what I'm going to have to do is to yank this, paste it here, rename this one to 16, change this one to 16, and then there I just need to verify the value, which I set to be 124. That's literally what I need. Put it there, 16. Actually, this, I mean, I guess if I exit early, it would just return something else. Now, unknown type CD, which is what I was looking for. Now I'm still getting this sec fault, which is actually yeah, because even if I don't know the type, I'm just going ahead with it. I'm not like returning. So I'm starting to read into garbage positions. But now I know what I need to do next, right? Because I got this error-driven thing. And the next one is going to be, well, actually, you just need a copy of this in here for you in 16. Ah, but you don't know what 16 is. It is CD. Okay, then you can go back there. And your size is actually, we can look at it, but I think it's not going to be 3, it's going to be 4. Actually, no, it's just added 1, and it's 32 that adds 2, and then 64 that adds a gajillion. So this one is just an extra one, so 3, and next is still +1, which is simple, right? Let's go header size, int, yeah. So this should be fine. Now if I do this, then I should get a different error, which says wrong, and I got 0. And the reason why I got 0 is because it probably fell through this without doing anything. Now I can say if the size is 3, then the value should be a little bit more complicated than that. We're going to start with this. So first, I'm actually going to get next at 1 and set the value, and then followed by value equals uint 32t of item next 0. So I'm going to get what's there and then what's there. But I want to move this by 7. I just need to make sure that 7 is what I want. I think I want to move it by 8. Because 7 would just be off by 1, so I'm just going to do that. And instead of doing equals, it's going to be a or equal. Because I want to add them together. And just to be extra safe, what I should do is say, by default, I'm going to set the value to 0 to make sure that, like, if I'm given some garbage, actually, no, I don't need to do that because this is going to take care of it. Now, the risk there is it might try to do sign extension, which is something that I've learned recently and caused some issues. So to be safe, I'm going to do this. And I'm going to say, make sure that everything on the left of those 8 bits is going to be set to 0. And to do that, you do 0x ff. So ff is going to be 8, is going to be 1 byte. And 1 byte is going to be set to 1. And everything else on the left is going to be set to 0. So that way, if after I do this, actually what I should probably do is do it like this instead. Like this, just to make sure that I'm not doing the ff on the item, which is a byte. Yeah, so I think the theory is correct. Let's see if it passes the test. It passes the test. So now I can read those. Now that we've done this one, because we're going to file for the 32, let's try to speed the 32. But actually, I can now see a pattern emerging there, which is going to be basically do this and validate, like it's going to be load a file into a buffer, initialize the root, assert the root to be a specific type, and then do a specific read operation, like a root read, and then check the value against something else. Now for the int, it's going to be quite easy. So I'm actually wondering if I should just try to have something that I can reuse for this. How would I go about that? Now I could make a macro, and that macro would define the test function, or I could have a macro that just creates the body of the test function, so that I could just do it from the outside. I think what I'm going to do is a macro that loads, so I can separate it. So I can say load root, right? And it's going to be kind of like a just the file that I need, right? And this is going to be this. I'm going to put it here and put some stuff there. Okay, and I'm going to remove this one, right? And then now I should be able to actually replace this with X, and in there I should be able to do load root data uint 8.bin, and I can just delete all of these. And then I think I'm gonna have another macro which is gonna be define assert int value, and I'm gonna give it like an x, and this is gonna be this. And then I'll need to figure out what I'm going to do with the free and stuff like that. This format, and I realize now that I need what I want to, and then the val, so the expected val. So this is going to be val, and instead of root, I'm going to get x. So now I can actually change this to be expected %d got %d. Expected is going to be val, and the other one is going to be the other one. And then exit one can be something else. I'll just need to figure out what I want to do with this. I think what I may want to do there is I don't know if it's super elegant, but I may want to have like 2 labels and then using a goto, which is not ideal, but I think I'm going to leave it like that for now. Do an exit. I might even just free buffer. I'm just going to ignore that for now. I'll just sort it out another time. So now I should be able to do assert int value with root followed by 129. Now that's going to be able to delete all of this, and now my test becomes much better. And if I just copy this, paste it there, and do a 16 followed by 16 followed by 124, now I should have replicated the 2 tests that I have in a much more compact way. Good. And I may want to have something that just wrap it into something that says if the result is good, then pass it. But now I should be able to very easily go and say test uint 32, and then int, and then now I can test the value, which was this big boy. This is the one that I tested, this one, and run the test. Nothing changes because I'm not calling the function. Run the test, and I got some stuff, but it says I don't know what CE is. Now this is very familiar. Maybe I can go here, say 32 is CE, go down here, do some kind of repetitive thing. It's a bit annoying to have these like big thing with like the branching and everything, but at the same time I feel like I could spend way more time abstracting it and trying to have something that automatically you know, finds the right thing with the right size and everything, than if I just left it like that as just a big logic. This is very kind of readable and understandable in a way. And I put 5, but I'm pretty sure it is 5. 1 plus 4, so that's 5. Now if I do this, I should get the wrong value, which says expected this got 0. Great. Which lets me copy this and go into 5. And I read the first value with the mask. Here I'm not masking the thing on the left because this value is shifted, which means I don't think I need to, although in a uint32 there's quite a few, so I should probably mask it as well. I'm going to do that on all of them just to be super safe. Which is where I can start introducing a pattern, which is 8 times 0 and 8 times 1. Now this might look a little bit silly, because it kind of is. But it'll make sense when you start doing things like this, where you go do this, and we're gonna go now I'm gonna go to 4 values, so 0, 1, 2, 3, 3 and 2 and 2 and 3 and 0 and 1. So to just re-summarize what I'm doing here for this one, I'm grabbing the most significant, no, not most significant, I'm grabbing the byte that is the most to the right, so this one, which is at index, this is 0, 1, 2, 3, so I'm grabbing 3, and I'm masking it to make sure, so I'm casting to uint32, so I go from something that could only have 8 bits to something that can have 32 bits, and just to be safe, because sometimes there's a thing called sign extension, and it could have set all of the zeros that I expect to be zeros to 1, just to be safe, I mask it with 0ff, which is 1 byte of just ones at that position. So now I have a 32-bit integer whose least significant bits are the bits of the item, like the byte at index 3. And then I move them to the left by 8 times 0, which means I do nothing. The compiler will just get rid of that, but it's just, when you look at what it does, then all the lines do the same thing. And I assign that to the value. So the value now has that, which is as least significant bits, it has the bits of the byte at index 3. And then I do the same thing for 2, except that instead of assigning it, I'm joining them. So I'm basically doing an OR operation. So if, yeah, I'm going to do an OR operation, and I ensure that what already exists only has zeros in the other one I compare. So I get the one at index 2, put it in uint32, do a 0xff masking on it, so I only get the least significant, the 8 bits that are least significant set to the values that they need, the rest is set to 0, and then I move them by 8, because this is time 1. And the next one's going to be moved by 16, and the next one's going to be 24. So that way they can like all merge together. I don't know if there's like a better way to do this. You could technically put it in a loop and say, decrease this value from 3 to 0, and in the value that you get there, you just get 3 minus the value that's there. And you could do an OR on it, because technically I could just do OR equal here, right? Just for like the aesthetic, right? I might, you know, but I'm just going to do equal here. Earlier on, I initialized value to 0 at the top, because I was like, oh, that way I make sure that when I OR them, there is no problem. But because the first, in every case that's valid, the first operation I do is just setting the value, then that shouldn't be an issue. But yeah, that's the situation. So now, is it going to work? It works. Now I'm going to do 64. Now for 64, I'm actually tempted to basically go and say, let's introduce like an actual read uint, read this, like read uint 8 uint, 16 uint, 32 uint, 64, because these types, they actually do exist. Like I could have those, but then it means that the user of this library, which is going to be me, would need to look at the item and know ahead of time that it is an item with a specific size. And to do that, then I would have to expose some kind of function that says, for this given item, assuming it is an int, what size would it have? And technically this is what this is, because this would tell me this has you know, 1, but like the 2 is incorrect there, the size would be 1. The 3 is incorrect because it's 2 uint 16, so 2 bytes. So I could do like this, -1 with 1 being the max, but I don't know. So I don't know what to do with the 64. I could either say, when I read an int, I always get a 64 back, a uint 64, because that's the max you could get, and that's it. Or I actually say int and then int 64, but then I need something that indicates to the thing that is int 64. So I think I'm actually going to do the first one that I said, and I'm going to swap that to 64. which is also where I'm going to change this one. 64, 64. Right, I'm going to do that. Obviously, I need to then go to MessagePack H and change the read int. It's not the most efficient library, obviously, because that means that even if I'm reading a uint 8, I'm going to get a 64 out of that. So not ideal, but yeah. There's also the fact that, like, if someone sends me a unsigned int or like a signed int, I'm reading all of them as like unsigned. So I may introduce the U and S variant, or like the normal signed and then the unsigned variant, because this is signed. And then there's the negative value, which I don't even know what to do with that. I guess I'll just need to support those separately. But I'm going like a bit deep in like implementing the int entirely. I might not need for VS, but I think this is something that's interesting to look at. Right, so the last thing obviously that I need is going to be this complicated, not so complicated, but a uint 64 is going to be a really big number, and I don't know exactly how to test it. Like, how am I going to get a 2 to the power of 64 minus 1? Because I got the E, like I got this notation there, right? Ah, I actually got this, right? So 16, okay. But 15 is going to be the one that's minus 1. So this is the max value that can be stored. I mean, actually, I don't really need this. I just need something that is bigger than what the other one could store, if that makes sense. Because the other one could store, I said 1024, right? And that one could store, oh, this is where I'm a bit confused. Maybe I should do 32. What's 32? Okay, great. Something that's bigger than this is what I need. That's as simple as that. This, and then if I move to 6, it should go to a bunch more, right? So I'm going to save this into my little library of binaries to test with. And uint 64.bin. Then I'm going to save this number as the one that I'm expecting. Yeah, obviously that's going to start causing some issues. I'm going to just paste it there for now, and then here, now you need to use 64 for stuff, which here is going to be 64 as well. I'm going to change them after. Format specifier. Format specifiers, where would that be? Oh, it's because I'm using, it's in the it's in here. Instead of D, I should probably do ZU, I think. Unsigned long. I just don't know these. Let me try this. I'm gonna expand, see what the error is, and oh, I know what it is. I'm gonna cast this one like this. Okay. Right, so this is fine because I can just use it. All right, so now I can just go and say, yank this, paste it, 64, 64, and delete this, and paste it, which obviously didn't work because it was in its own line. Paste it here, missing the space, go there, yank, 64. And that should fail. Ah, I forgot that I still got errors there. And these are just warnings I don't really care about. Okay. right? And it fails because it says doesn't know CF. It's a bit of a grunt work here, just like add this one, do this, do that. But yeah, we'll need that. I think the one that I should have started with maybe was strings, because there's going to be so many more strings that are like longer than what I can support right now. So here I'm adding 4. I had 4, I'm adding 4, so it should be 9. Which means here I should be able to copy this and do 9. And that means that instead of starting at 3, I need to start at 7. 7, actually I'm going to keep it at 3 here. Put an OR there. And the only difference there is that, actually, let me just start from the top so I don't get confused. 7, 6, 5, 4. Sure. And I need the double. And 3, 2, 1, 0. This is what I need to. I'm just retyping something. Why is there half of them that do not have the right brackets? That is not going to be good. And these need to go. I have to tidy up the others as well. Okay, and then here I do need to basically start 0, 1, 2, 3, 4, 5, 6, 7. Okay, that's correct. Now obviously I'm going to start. So why would I start having issues at that point? It's bigger than the width of the type. Is it because I'm doing I'm not doing the right order of operations? It's possible. That's what it was. I need to have this syntax instead of the other one because it's just it's just better in general. But let me just fix it there, because this is kind of correct but not really. I need one here and I need to add more here because I want to be very explicit with the order of operations. I want to make sure that like the stuff is casted first, then masked, then bit shifted. I don't want a mask to be bit shifted. That would be not good, which means I need to add one here. Although it did work originally, I still want to make sure that it's done properly. This one should be kind of okay because I'm just bit shifting, and this one is kind of okay as well, but I want to make sure as well. Right, so this should be what I need. Test passes. So now I support all of the uints or whatever. The thing that I'm not sure about is, I mean, obviously the way the bytes are over the network, or like when they're serialized, like when the number is serialized, the way the bytes are will be arranged in a way that makes sense to the sender, but the receiver should also receive it the same way. So I don't think that there's a change in. That's not true. For the same number, if it's unsigned or signed, it's obviously going to be different bytes, which means that right now the only thing I do support is uint, because they were specifically uint, right? And it's big Endian, and then the signed is signed version. But I think that the only thing I would need to do is move the bytes in the right place, and instead of casting it to an unsigned, if I cast it to the signed variant, then it would just work. So I think that what I may need to do is to rename my current type from int to uint, add another type called int instead, and have the exact same logic, but the only thing I need to change is the signed version. But let's just pause here. We have something that's like kind of working, and I do want to get started on, so here's the plan that I'm going to try to do to wrap it up. I basically want to re-implement the current logic that we have with the OBS client, right? That just switches to one scene. And I want to re-implement it in a way that I can get the bytes, I can get a string from the CLI and use that as like, this is the scene that you need to go to, which will be very simple. But to do that, I need to be able to write to create a like I need to write some bytes, right? And I think this is going to be easier to write the byte because you could literally just say, I'm going to write this number, then I can easily check how big the number is, right? And if the number is smaller than a small number, and then you write it this way. If it's smaller than the next one, you write it this way, and then you can just write them out. The challenge is going to be, do you have enough space left in the buffer? And if you don't, what do you do about that, right? Because you kind of want to know ahead of time how much space you're going to need for what you're trying to write. But I think I'm going to ignore that for now. So I think that what I would like to do, I mean, the one that's going to be super easy is to say, write uint. We'll start with that one. I said, let's write a uint into the buffer. And that's the logic that I just described. That should be easy enough. But when it comes to writing arrays, I may need to do something which is, you have to write the header and then write the items. Yeah, I think that's fine. Yeah, that should be easy. So let's just start here. And we're going to have a new kind of set of things, which is going to be enum mp result. So now we can use that. mp write uint. And then you don't need like the item or whatever. You literally need uint64t value. And before that, you probably want to get a unsigned char pointer buffer. And then now should you provide the size of the buffer? Because the thing is, when I'm going to do that, I'm going to move forward and say this is where you are now, because I probably need to return like where you went. So this is where mp result might not work. But do I need to provide the size? Because when I move, then I have to reduce the size. But the reality is I want to know where the end is. I could have something which is, I have a writer, an MP writer that is initialized with a buffer and a specific size. And every time I want to write to it, I just read that, and now I got the size. And when I move it forward, then I can decrease the size and move or at least move the pointer in there. Because I'm just thinking the most common usage is going to be, I have a whole structure that I need to write. And every time I write, I need to move forward the pointer to the thing. And how do I know if I went over, right? How do I know if I'm about to go over? Unless I query and say, I'm about to write this uint, what size am I going to need? And then see if that fits. That's going to be an issue. And I don't want to be writing past the boundary. So I think I am going to do a size t length and just put it that way. Now what I'm going to do actually here is return a unsigned char pointer. If it's null, then something went wrong, like I couldn't write. If it's a value, then it's I just moved it. So I could return and say, here's the number that I wrote, but I don't know. The only thing that I would be worried about is like, this is the syntax. It's going to be unsigned char buffer, right? And then it's going to be mp write uint buffer max length or something like that, and then 64. You want to write this value, and then it's going to have to be buffer equals this, right? Oh, it thinks I'm not. Yeah, it's just I need to be in a. Let's do that just for the sake. And max length is, it doesn't matter. Sure. It doesn't matter because it's not real code. So this is kind of like the interface that I'm going to have, right? And at every stage, I'm kind of going to need to do something like this. If buffer is null. But then if I do that, then if I set my buffer to null, then I've got a problem, right? Because I don't have a pointer to my buffer anymore. So I think I should change it and say, what you're going to get back is a uint32t, which is going to be uint32t, I'm going to say return, right? And then it's going to be return. And then you're going to need to do something like this, which is if return is 0, because there's no scenario where you would write nothing, then you would need to do an early exit or something, right? And then otherwise you need to do buffer equals buffer plus return, unless and you'd kind of lose the start of the buffer, which is an issue. So you might want to have something. So I think I am going to do a writer because it's so much more convenient. Struct mp writer, and the only thing I'm going to need instead is unsigned char pointer, which is going to be the buffer to write into, with a size t for the length that I have, and then I either store a position, which is going to be size t, or a pointer where I'm at. So I might as well use a pointer where I'm at, because size t or unsigned char pointer is going to be the same size, so I might as well store one that's like a bit more convenient. So I'm going to use an mp writer. So that means that I don't need this, and I can just say struct mp writer star writer. And the way you're going to use it then is going to be, you've got these, and you can say struct mp writer just writer. You're going to need to have an init in there, which, sure, you're going to need to have an init. So mp writer init. You just get a writer with a unsigned char pointer buffer with a size t length, which should you don't even need to do anything there. Void, right? So you're going to do this, and then you're going to do mp writer init and writer. Now, of course, you need to do the buffer and the max length, and you don't need return anymore technically, although it's nice to have. But I can just say, yeah, I can still keep return, even though I'm not really reading it. And write uint is going to be end writer. Now, when you do this, I'm going to internally move the cursor so I know where to write, and then I can simply check if the cursor minus the buffer, or before that I should do cursor plus the size that I'm about to write that I need. If that is bigger than the and minus the cursor, if that's bigger than the length, then I can just return 0 and say there was something wrong. And this, like the return, if it's that exit, I can have that in a macro, which would be check writer, whatever, and I don't need to add this in there. So I do like this syntax. So because we're going to do some tests, what I'm going to do is, there's another thing that I was thinking about, is that if instead of having a buffer, I had something that would let me directly write to the network, it could be interesting, but I think for really huge payloads, but I don't think I need that for now. I'm going to put it here, and I'm going to stop putting it here, which is going to be my write stuff. And here I'm going to say test write. I'm gonna try that, and I've got the writer and everything. Now these init and write, they don't exist, so obviously I need to do that. And while I'm here, I might as well do define assert write with x, which is going to be equal to if x is 0, exit 1. I'm just going to do super dumb and simple, although I should probably say something first. Failed to write. Right, I'll do that, which means here I can just say assert write, and I can just delete this one and delete this one. So that should be like quite simple. And then from there I can, once I have this, what I can do is just say max length, and obviously this is going to fail immediately, but here I can just say start with this, and then now I can I guess I can write the thing that I want. So if I want to write 64, I know 64 is going to fit in the 7 bits that the first one is. So in this instance, what I want to validate is that if buffer at 0 is different from MP disk. Ooh. Testing the disk is going to be kind of annoying if I don't have them in available in. I might for testing it's going to be quite convenient to have them in the header, but like, do I really want to leak the some of these? These make sense because it's just like, yeah, you kind of want those numbers, but like the one that says check those first 4 is more of a util than anything else. In here, and I can just go here, and it should for sure be a int, right? Not anything else. And if it's the case, then I can just say printf failed, which leads me to actually doing something like this. Define assert x if not x, printf exit 1. It's just like my little local thing, but here I can say failed, comma, so what a failed, so I would say expected space and x. I think that's what you need to do, because when you do that, then it just expand the thing automatically. So there I can just say assert and do this, and this should expand to, you see, expected, and it has the thing buffer at 0 needs to be this value. So actually the expect should be equals, and even better than that, I think what eventually I should have, and this is where my other tool is already there, x and y, and you can say if x is different from y, you can there say expected, and then do this hashtag y. So I say I expected this to be different from this, and actually here equal is gonna have to be double here, so I can do double here. And actually it's interesting because with the assert you can actually just you could provide the comparator as well. I don't know if I want to do that. I will keep the assert equal for now. So you're going to want to do that. And then the only thing that I want to add here, I'm actually going to start with failed, comma, this, not comma, but colon, full stop, expected. Oh, this is where I can't actually just put the thing there. Okay, let's ignore all that. It's gonna be easier to keep it like that. So let's do that, and finally test write. And if I do make test, it's gonna fail because the functions don't exist. So I just need to go to MessagePack H, grab the two functions that I've created, or at least the signatures, MessagePack MessagePack C, and I can just go, sure, why not, at the bottom. I'm going to start with the init. Init should be one of the simpler ones because it's literally writer at, I don't remember if it's buffer, is buffer. Writer. Length is length. And the only other thing is that the cursor needs to be the buffer. Just need to initialize it that way. And then writing the uint is going to start with if value is smaller than, what's the maximum value you can get into one unsigned byte, character byte, which is 255, but actually 7 bits instead. Well, that's easy. You can come here and say 1, 2, 3, 4, 5, 6, 7. 127. So it is unsigned, but it's 127, that's the maximum here. So if it's smaller than 127 or equal, so smaller than 128, then you only need to write into the buffer 1 byte. So you can do writer cursor equals value. Okay, but I also want to set the 7th bit to 0, force it to 0. So and I'm going to grab the number 1, which is going to be the least significant, move it 7 times to be the most significant, and flip it so that I have a 0 on the left and a bunch of y's all the way to the right. And writer cursor plus plus, obviously this, and return 1 because I've written 1. Now this obviously is going to cause an issue because I need to do it at 0. And here I'm going to say return 0 because I didn't know how to do that. Let's see. Test. Oh, I need to have so expected buff to be mp disk int. Okay. I guess the problem that I have is that maybe actually mp disk int. No, that's actually 0. So maybe I've put the wrong number in there. Because I'm not comparing. I'm not testing it properly. I shouldn't compare the disk int. I should just compare something else. If I write 64, I should expect 64 plus the value that's on the left. So if I go here, it's a bit odd, but if I swap and say 64, convert, then swap, oh man, 64 converts. It's so annoying that you just can't keep it there. That's interesting because 64 is exactly that. So how do you write 64 in this? I guess you force this one to 0, but then I don't have 64. Or am I just thinking about this the wrong way? I think I may have got that the wrong way, because this is, oh, I'm so dumb. This is 64, isn't it? Yeah, there is an extra 0 that's not shown. That's why. If I convert that, then that should be 64. Great. That's simple. It should literally be 64 because it's always a 0, so I should just check against 64. Let's just do that for now and then find a better way to test stuff, because the reality is once you're like once you're baking it, unless I'm comparing it to something that I've have an external source of truth, the only thing I can do is reparse the buffer using my own tool and check that it's an int with 64. In which case, if either the reader or the writer is wrong, I can't tell which one it is, or have these sentinel values that I have. So here I'm going to have to say 64 specifically, in which case it works. And here I'm going to want to say \n just to make it clear. Okay, so I can write an integer of a small with a small value in there, right? I wonder if what I could do is kind of like reset the buffer by just doing this and just put it after. Don't know if I want to make a bunch of functions, but here I now want to try to put a bigger number than 127. I'm going to put 132, right? And then here I'm going to expect this to be MP disk, and this time it's going to be unit 8 because I know it's smaller than that. And if I do this, fail to write. What would I get if I failed to write in this? Well, I guess I don't support the type, so I left it to return 0. Okay, that's fair enough. Else if value is smaller than, and this is where the next maximum value is, which is just this was 256. So if it is 255, it's good, which is the max value. Then this is where I can write at 0. I can write MP discriminator unit 8. Go back here and restart some music. I really need to get like some more variation. And then at 1, I just want to put the value, and I want to make sure that I've casted it to an unsigned char, right? Because I'm grabbing from a big value to a small value, I'm not going to trim or whatever. And then here I can just say plus equal 2 because I've written 2 and return 2. Test it. Works. Now I should be able to grab this 3 lines and just test. And obviously I should probably check that the one, I mean here actually, this one should be easy to check because I can say 132 at 1 because I've reset it. That's fairly easy. And in here I should be able to say this one's going to be 16 this time, and I'm not going to test the next one. Now 255 is the max I can put, so I'm going to say how about 276 just for a laugh. Now I go here, fail to write. Fair enough. The way you write this is by saying value smaller than. Now what's the next thing? U in 16 is going to be it's the 36,000 value that I don't know. I wonder if I can do actually uint 16 max. Now uint 16 max is going to be the 5, and I want to say equal because that's the value that I want. So I'm going to do that. And here I may be able to say uint 8 max. Yeah, and I do want to do equals. And this one is just a specific value that I need to keep there. Now I should be able to do this. Now this one is going to be more interesting because first of all, a uint 16 is just one more, but I cannot just put the value there. I need to put the least significant bit at 2, which is this one. But for this one, I actually need to grab the value and make sure move everything by 8 and erase everything else, 0xff. So let's do it this way. Move it first, erase it next. Actually casting it is going to take care of that, so I don't need to do anything. So I just need to do this. and then this becomes 1. So I'm grabbing the most significant byte, so the most going to be of the uint64 value, and I move them by 8, and then I cast return sign char, so everything on the left is going to be erased, and that's going to be 1, and then this is 2, and this is 3, and this is okay. Test works. I think I'm gonna do here the others quickly when I'm here. So 32 max, 32, and this is where there's a uniformization that comes here that I'm also going to put here just to make it nicer. 0, and this one is 1. So it kind of gets more formatted that way. This is going to be times 1 and 8 times 0, and I'm just going to grab those together. Okay, and this is where things is a little bit different, where I do want to do 2 more. Actually, I do need, because I'm doing 5 here. So 4, 5, and 5. Okay, and this is where I need to do it this way. So this is going to be 1, 2, and 3. Okay, and then finally grab this whole thing, yank it, paste it. This is going to become a 9. This is going to become a 9. This is going to become a 64. This is going to become a 64. And then the rest is the same, which is grab these, yank, paste them. This becomes 5, 6, 7, 8, correct? And this starts at 0, yes, which means this one goes to 4, 5, 6, and 7. Let me just confirm that. What I put the earliest in the buffer is the most significant bits of the thing. Yeah, which makes sense. So I should be able quite easily copy this one and say the next big value is that uint 32 max plus 4. Right, and put 1 just to test it, and then this one is going to be actually no, this one's going to be uint 16 max, and this one is going to be yeah, and this is going to be 64. Let's try that. Expected buffer to be 64, but I didn't get that. So I expected uint 64. And I tried to write uint 32 max plus 1, and I wrote the wrong thing. So it's possible that I didn't update the value there, right? No, I did. So if it's equal to uint 32 max, you should go here. If it's smaller than uint 64 max, but this is technically should just be an else here, if I'm being honest. Let me check if it's my test that's wrong. 16, so this should fit in 16, this 16 should, and then this uint 32 max plus 1 should fit in uint 64. Okay, and when I come here, my value is going to be uint 32 max plus 1, which means it can't branch into this, it's going to have to come here. Now cursor at 0 is going to get uint 64, which is CF, and I return 9, and I set to 0 and return 9. So why would that be the case then? This accepts a uint 64, so that should be fine. Unless this by default is a uint 32, and doing plus 1 I just wrapped it around instead of testing it properly. That's what it was. yeah, it looks like if you just put a number there, it just does that. Okay, so I can write numbers. I'm gonna do writing strings now, and it's interesting because I haven't done reading long strings, although reading long strings is going to be easy. But I might want to do, let's do read first. Let's have a little fun with read and then do a write. So we're gonna write. So let's look at the different thresholds that we have for strings. We have one which is 31, then we have one which is 255, then one which is, no, actually this one is going to be, yeah, 255, one which is, what am I reading? 31, yeah, 8 is 255, so what is 16? Is 16, oh yeah, that's the one, that's the really big one. But I don't think I'm going to make a string that's that long. That's the thing, is like, how am I going to test a string that's that long? So let's do one that's 31, so I need 33, right? 33. So that's exactly, and if I put one more, then I should see BF change. And if I remove it, it goes back to BF. So that's the expected kind of scenario. So this is going to be a small string. So echo dash n, put these in there into xxd rps data str, I want to say fix str.bin, and while I'm there, I might just add one more, and echo that to be str8. Okay, next I want to go into my main for MessagePack and write like a bit of a test thing. So the same way I have all of these tests, I want a static void test fix str, and do it that way. And this one is gonna load root, which is convenient to have, and then assert mp type str. Interesting, that comes up. And then finally I've got assert in value. So this one's going to be if, well, first of all, I'm going to need a char pointer str, and then do mp read string of and root and str, free str, and finally if strcmp str and something that I'm looking for. So in this case it's going to be this. I should have gone something that's like a little bit better than that. That's not going to be ideal. If it's 0, then it passes, but if it's not 0, then this is where I do my my problem, in which case I'm going to do this, and I say assert str, which I'm going to get x and y, and I'm going to say if strcmp x y is different from 0, printf expected. Because there are strings, I could just put them in line there. I don't know if I should do that. I mean, they're both evaluated, so I could evaluate them. I think what I want to do is failed, followed by what I was expecting, which is equals equals, and say hashtag x, hashtag y, and I can potentially put a full stop there, and I say expected %s got %s, and the line return. And the way this is going to work is x is always going to be the expected one. I'm going to try to do it that way. So x followed by y. Now the problem is that obviously if I provide something in there in the assert that is like evaluated, that's going to be evaluated twice. So I may in the future change it to have something that I can just have a local variable that's kept there. I'm going to put that all the way at the top so I can use it. And now I should be able to go and say assert str with this big monstrosity followed by str, and then delete this, delete this, delete this, delete this, and then this can become define. And what did I do with the like int value? This is going to be define str value, so assert str value with an x, sure, and a y, sure, and then I can just say it's this, boink, and then this becomes the y. Don't know why this jumped, y, and this becomes the x. Assert str value, assert str value, and I give it the end root, delete this, delete this, delete this. Okay, and the data here is going to be fix str. Okay, test fix str. All right. Leaked memory, I don't really mind. I didn't get any error, so that's okay. But obviously I'm leaking at the end of read file because I should always kind of like free at the end of those. Okay. Right, so reading it seems to have worked. Now, if I actually go here and do a str8 and do str8 and go here and add a 3 here, add it to the list of things that I'm actually running, I should get an error. Expected type string got int. Right, and that's because that's not correct actually. So I'm reading that one and it got int. I guess it's because it falls off of the branch, but actually I guess the problem is that when I do load root, I am not actually testing. So this is the problem that I have here. I should say if this is different from mpok, I should for sure do printf failed called not initialize item, so root item followed by exit 1. And to be honest, because I've got a bunch of line returns here, I might as well just do this followed by this and this, and that's it. So if I do this, could not initialize root item, and it's normal because MessagePack C, when I go into initializing it, it just doesn't handle the string properly. And this is where I should grab this, paste it here, and str8. Now str8, according to the spec, is this value. So I can go to str8, which is in h, right here, d9, str8. Now while I'm in this file, I might as well just do all of them. 16 and 32 is dA and dB. A, B, 16 and 32. Just so I have them, I don't have to just work through it. So now if I've got this, item type is MP type string, sure. Item size is going to be 1 plus the size of the string, so I need to sort that out. So actually this one's easy. Item data at 1 plus 1. Which one again? Like I need to make sure that I do a uint64t, or I should say size t, before I add the 1, just in case. And finally, item next equals item data plus 1. Test failed. 3 equals string accepted but got, and I'm missing 1 item. So is it just size that it does something wrong with it? Because technically I do size minus header when I read a string. Header size is next, so that should be 1. Then size minus 1 is string. Then I allocate that plus 1, and then I read those into there, and I set that to 0. So I'm not sure why. Well, interestingly enough, there it looks like I may have a space at the beginning of my thing. Let me check that it's not something in my my logging. I only got 1 space there, so it looks like it's everything shifted by something. So I might be reading the right number, but I'm starting 1 too early. Yeah, so I may be reading data instead of reading next, which would cause the exact same issue. One thing I'm not too sure about is I'm missing spaces here. Okay, so item next is what I'm reading. So is next not set properly? But next is next is data plus 1. String 8. Oh, it should be data plus 2. What's the normal string do? The normal string has data plus 1, so yeah, it should be data plus 2 for sure. That makes more sense. Failed. So now it looks like my size is not correct, which makes sense because my header size is something plus 2. Okay, correct. I don't think I can test a string 16 because that means I need 65 kilobytes worth of string, and that I would have to check all of them when I'm reading it. So I don't think I can, like, realistically right now try it. I'm also gonna end it soonish. So yeah, I'm not gonna do it right now, but I do want to try to start writing strings and then writing maps, and hopefully strings and maps is all I need. Because if I look at my if I look at this one, let's see what I write here. I write a map with string number, string map, string number, and here map with string number, string map, string request ID seems really odd. Oh no, it's because I'm doing it. Yeah, so string. I actually want to put this one back here if possible. It would look better. Oh, it's the formatting that did it. So string, string map, string. So the only thing I need to do is just to write the right number of stuff ahead of time. So yeah, and all those strings and those numbers fit there. So yeah, let's just do a writer. So let's do write string, write map, and then we're going to come here and hopefully we can switch to MessagePack and it just works. Because I don't need to read anything from it yet, so I could just completely ignore what I'm receiving and just do the writing, because I need to write these two payloads and that's it. So let's go back and say let's have a test area that's going to look a lot like this one, and this one is going to be test write int, and I'm going to copy that to start with and do test write str. The thing is I'm only going to write one thing anyway, so max length now, write string, and I'm going to give it a C string, which is testing. And I'm expecting, because this one's really short, I'm expecting buffer at 0 to be a combination of like the string length plus something else, right? So what I need to do is 101, so it should be 0b101, and then 1 2 3 4 5, and strlen of testing. That's what I'm expecting as like a result. Okay, write string doesn't exist. Sure, it's because I never made it. Const char str with write string. Yank that, go to the message pack and write here size t length equals strlen str. I could actually swap it to just say I'm going to give you the length instead of forcing a C string, which probably would be better, because if you ever have data that comes from somewhere, if you have a string view that's not terminated, you can then interrupt with that. But let's just not worry about that right now. If len is smaller than 32, then you can fit in the first one, in which case writer at cursor 0 is 0b101 1 2 3 4 5 and length. Don't know what I can't write writer for some reason. Writer cursor, and this is where things are a little bit different, because that's just a number, and now I need to do memcpy at the cursor 1, the string with the length. Definitely want this, although I could do this and plus instead. I think that works. And then I'm going to do writer cursor Is this where I could use mempcpy? Because I think it returns. Let me check again. Mempcpy function is near integral to memsqy. It copies n bytes from, yep. But instead of returning the value of dest, it returns the pointer to the byte following the last written byte, which I think is exactly what I want. So mempcpy with writer cursor. So it's going to move the cursor, and the last thing that I need to remember is return, and I've written 1 plus the length, so length plus 1. And here I'm going to have to say return 0, which basically is a problem. Let's try that. Make test. It's going to work because I think I forgot to add it to my list of tests that I run. str8. Oh, str8. Yeah, write string, write str. Okay, seems to be working as well. And I do want to test. So what I need is these 3 lines. So I reinitialize, and I do want to test something that has more than 32, more than 31. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. No, I'm doing something better, something more clever. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think if I format it this way, just realized that this does not seem to be 10. So I'm writing 32. And basically what I need there is 0 needs to be mp disk str8. And I need something else that could potentially check the string, but I'm just going to leave it like that. If I do this, fail. It's not the right value. But if I go back here and I add an else, I can then easily say else if length is smaller than uint 8 max or equal. It's more equal. Yes. Then I can definitely do writer cursor at 0 is going to be mp disk str8 followed by the actual size, so it's me len unsigned char length, and then the memcpy of +2. Yeah, and then finally I return length +2. Test it. Error. str8 disk str8. Okay. So what's uint 8 max? It's 255. So it should come in here. Unless I don't init properly. Buffer at 0. Unless this is not 30. I mean, this is 10, 10. Oh yeah, of course it's not. It's 20. It's 22, not 32. Correct. Right. So now I should have all the tools I need to write what I need. So let's go to main.c here. And actually, let's go to the makefile first and update it so that I can actually make it work with my library, which I'm building. One thing that I realize I can do, I mean, because it's not in the same makefile, it's not going to know that when I change the library and update here. So we're going to have to manage it that way. But one thing I can definitely do is here, I can add MSGPack. Let's not forget to have this in there, which is just fine. And actually, I should definitely just make it smaller. Include is going to be MessagePack because the include is there. And when I run it, I just need to remember that when I run it, I need to specify the LD library path because it doesn't really do that. So for that, what I'm actually going to do is something a little bit stupid, but not really. Run is going to depend on this. I'm going to paste it there. And then I'm going to say run is $in, so the first file that's there. And before that, I need to do LD library path equals msg pack /bin and then run this. I don't know if that's going to work. Make run. Okay, I need to remember that every time it's going to switch. So this seems to have worked, and I don't know if like run did, but I'm not necessarily using it just yet, so hopefully that still is going to work. Let's go to my source main here. So WS implementation is there. Okay, it doesn't matter, so that's WebSocket. First msg pack and see how things are going to fail. Your session for the section impact, but a text message was received. Okay, great, and it didn't do anything. So that's the data that I got, which this I would reckon is part of MessagePack. And I got close right away. I got a handshake with something in there. That's correct. So handle read is correct, but I sent a text message. So this is the payload that I have. So in here, what I'm going to do instead is I'm going to say enum mp writer mp writer init with the writer followed by I'm going to need a buffer, so I'm going to say payload and max payload length. I just don't know. For now I'm just gonna hard code some of those values, and char payload 1024 exists, right? It's probably because I'm not including MSG pack. Okay. Use of MP writer with tag type that does not match. Oh, it's not an enum. It's a struct. Okay. I got payload, and then I'm gonna want to basically do. This is gonna have to be unsigned, and I'm obviously missing the right map, but I'm gonna blind this one, not make test for it, and then we'll see where that goes. Init needs to be that, and then payload obviously is redesigned. So actually, I'm gonna call it buffer. No. Payload is fine. Okay, and then here the only thing I need to do is to basically say mp write map with the writer followed by how many items in the map I'm going to need, which is going to be 1 for op and 2 for d, so 2, and that doesn't exist. But then the only thing I need to do is mp write string and writer followed by op, then uint with 1. Okay, and then I'm gonna need to start another map with 1 item, and that 1 item is going to be a pair there, string rpc version followed by 1. Right, so I just have that correctly, and wsend is going to be payload and srln payload, which the only thing I'm missing here is write map. So message pack header map is going to be probably one of the easiest one. Actually, because I only support a few number of keys for now, but map, and this is going to be a size. Let me check. What's the maximum size for the map? Maximum is going to be 32. So I'm going to do uint 32t size, or like count. Go to messagepack.c and put it there. And what I have to do is first, if count is smaller or equal to uint, well, actually, when it's really small, so 4, I'm not going to be able to do that then, because this one is 15 elements, so including 15, so I'm going to say smaller than 16, then writer at cursor 0 equals 0b 1 1 2 3 1 2 3 4, okay, and unsigned char count. Am I missing anything? I shouldn't do and really, I should probably do an or. An or if I erase 0x ff, if I erase the no, sff, if I erase the other one. So I need to do first this. Yeah, this time I'm going to do it like this and like this, okay? Writer at cursor plus plus return 1 return 0, okay? Right, so this is where it doesn't know that it changed. So I think what I need to do is make -c, I think works, and MessagePack, and it works, and I can do run, and I've got invalid UTF-8 encoding, so nothing changed here. Okay, so invalid UTF-8 encoding. So could it be that like the strings I'm sending, they're not in UTF-8? What is the encoding of C strings? Comparison you probably should. I don't understand. I don't understand what it says, like there is no encoding. Like that answer is weird. It's not really encoded. It is stored as is. Okay, but we have mapped, like when I actually print stuff, we have mapped a number, right? So it's probably ASCII. So UTF-8 encoding C. That might be more complex. If I have to encode in UTF-8, and this one is like a whole thing about like 1 out of 3, 12 more parts, like all that stuff. Speaks UTF-8. Okay. C90 introduced WHRT and a bunch of functions to deadlining, dealing with non-ASCII encoding. We always found it. Okay. Well, this might actually be simpler than it seems. Although, if it's going to have basically changed the size of it, that's going to be a real problem. But yeah, let's remind myself how UTF-8 works. Actually, it's very simple. Given a Unicode code point, character, even if we know it's not a code point, its bits are spread into multiple bytes according to a Boolean table. Range, but like, what does it read the range of the first? I guess it does read the range of. It must be minimal, so smallest point of a byte. Okay. Code point this and this are valid, invalid, and encoding valid. Okay. The first 128 characters occupy just 1 byte, and their encoding is the same both in ASCII and UTF-8. Okay, so that means that for everything that's under 128 characters, then my UTF is correct, and I'm pretty sure that I'm sending something that is less than 120 characters. So let's see what I could have done wrong by encoding. So let's see. Oh, I think I'm missing something. I think I'm missing something. In here, I say do a map, string value. I forget the string here. So I'm writing a map where I should have a D for the data. Invalid UTF-8 encoding, and I'm making sure that didn't change. Okay, well, at least I've got something different here. It's going to be difficult to figure out where that issue is. One thing I could try to do is to print the entire buffer and try to then give that to this thing, but this thing is not going to tell me actually exactly what I need. So I've got OP1 D RPC version 1. So this is what I'm supposed to get here. I'm supposed to be getting that. I could just print it. Oh, you know what? STRL of payload. I'm sending too much, right? Aren't I? What I need is not STRL of payload. I mean, actually, it would work, but then the problem is if I find a 0 there, I'm going to send something that's not correct. What I need is writer.cursor minus writer buffer, which is technically the length of it. I don't know if that's going to change anything. Okay, I still get the same error, but at least now I should be getting something that's a little bit better. So for uin32t, I is 0, I is smaller than writer.cursor minus writer.buffer plus I. I'm going to get payload at I, and I'm going to do a printf of the hex value of that. And when I'm done with all of them, I'm just going to line return it. And I'm just going to go crazy and say exit 1, so I don't have to worry about the rest. Okay, I may want to add a space in between everything. Okay, and I think I can do this. And 0. Yes, okay. So this is what I have. Okay, that's what I have, and this is what I'm expecting, and then I can try to start to see where I got it wrong, which, to be honest, it's already, the length is correct, but I can tell already that there's a problem there. These actually synchronize perfectly at the end, but the map doesn't seem to be storing, unless there's this A2 that's wrong. Oh, for every map I'm supposed to have a 0, I think, and I'm putting A1 and an A2 and A1, and I think A2 is saying I've got 2 records, and this one is going to say, no, this is too big. This could be the, this is actually I've got 2 records, and this is I've got 1 record, and A2 is actually the start of my string, I think. Well, actually I should have A2, I should have A2, and I'm writing 0 for some reason. So it's possible that I'm actually moving, not because I'm aligned on all of the other numbers. The only numbers that I have is every time I need to write a string, which is here, when I need to write OP followed by 1, OP followed by 1. Then this is the header, and this is the D. So 0, 0. Why would I need 0, 0 when I write a fixed string? Because I think I am writing a fixed string, right? I'm not writing anything else. It can't be 0, 0, right? Oh, but I'm writing 0, 0. Well, actually, I should be writing A2 and A1, and A2 is going to be OP and A1, so it's the number. So A is the letter that's there. So it's my string writing that's incorrect. MessagePack.c, write string. Yeah, so because it's an or here, otherwise it would just obviously fail. Okay. Now this seems to be exactly the payload that I should be expecting. Yeah, perfect match. So my encoder is now for a subset of the thing, MessagePack, seems to be compliant, or whatever you want to call it. I'm not gonna, I'm just gonna keep printing, and now we're gonna run it. And I still get invalid UTF-8 encoding. But am I sending something else? No. Why am I printing 23 here? I guess it's just the length, right? Isn't that odd that I could try to print it as well in a weird way to see if I'm getting something similar. %.s payload and writer.cursor minus writer.buffer. Maybe it's still that's a problem. OP something D RPC version 2. Oh, it's because I'm not putting a line return here. RPC version has got nothing at the end, but it's either that I'm not writing the one correctly, which I should be, or that the one doesn't show. I mean, I could try to put a bigger number, like if I put something bigger than, if I put 200, it probably would look a bit different. Yeah, I'm getting 2 of these characters at the end. So what I find odd now is that when I go here and I say, please encode this, which is the payload that I need to send, I get the exact same bytes that when I encode it, but when I give it to OBS, it complains about the encoding. So there's either something wrong in the way it is sent, if I'm modifying it in whatsoever, or maybe this is too restrictive, but it shouldn't be, because I've been writing these values cursor minus buffer, and it gets me the exact bytes that I need, and when I print it, it seems to be correct. So I'm slightly confused there. Unless I'm not writing the right thing, but I am, right? Because I do write map op int. Let me just like format it so I can see what's going on. This is like 2 values. Then I do a D and map, and this is 2 values. So string and uint RPC version, and it moves the cursor, and the cursor gives me a certain number of bytes. Right, it's gonna be time for me to stop anyways. And I wish I could have got OBS to accept my stuff. It didn't say anything this time. Oh no, it did. It sent me a clause and saying invalid UTF-8 encoding. But from what I've seen, if your string is less than 128, then your UTF-8 is equals to ASCII. Raw string, UTF-8 or binary. I could read the sources there, to be honest, right? What's in lib? It's in C++ as well. JSON. I'm not seeing MessagePack, so they might be using a library. JSON to MessagePack. So the question is when they decode it. This is sending, or is it what? Broadcast event. That's the protocol. Select sub-protocol. Set encoding. Client connected. On open. There you go. It sends something in MessagePack. Your session, yeah, okay, that's correct. Unable to do a message, unable to decode MessagePack. Is this what I have? No, I just have invalid UTF-8. Although this is kind of like, oh, that's what it sends back. And then there is, I'm not really seeing, what if I look for UTF-8? I'm not going to be able to do it because it doesn't let me search when I'm not signed in. I don't like that, like, I'm in this format and I had the thing open on the side and not this floating version, the actual fixed one, yeah. And then when I moved around, this moves and this floats, and then if I close this, then this doesn't reopen, and this, like, it's just so weird. Okay. I think they just have something that just says convert JSON to MessagePack. So it's not even that efficient. They probably just do everything in JSON and then do MessagePack as like a alternative support. So this is sending. Right, so opcode there. WebSocket frame binary, okay. So that's incoming message. Incoming message is JSON from MSGPack, which I can't. JSON from MSGPack. You know what? I think it's going to be in their JSON lib, right? No, not lib. util, and then they obviously have JSON, and they may have MSG. No, interesting. So maybe they use a library for that. Is there like a project thing that would say CMake list JSON? So this guy's JSON, which I've actually seen that name before. CPP module. Where do I find the code is my main question. Binary format to MessagePack, which is going to go to this instead of something else. That's just the includes. Oh, SRC is here, but there's only modules, tools. Where's the actual source? Is it all in the include? Maybe it is a single header file. It probably is. And I want a from. And actually I'm looking for a UTF. Okay. Sax DOM parser, binary reader. That looks so much more complex than it could be. Anyways, that's the end. I'm going to stop there. But yeah, I don't think we're far off. It's just I need to figure out why it wouldn't be UTF-8, and it's going to be a problem. If we have to encode stuff in UTF-8, it's going to be a problem because I don't know if I want to get into that. I don't think it's too complicated to do, right? You just go through them, you see what character it is, and if it fits, you do that. If it's bigger than 128, then you start packing stuff in different, like, you know, just do stuff like that. Actually, it's not even 128 in the length. It's if whatever character you're trying to write is within the 0 to 128 in ASCII, then it's going to be the same. So maybe this is where my UTF-8 is not correct. It's possible that I actually have a character that is outside of that value, which, you know what, let's test it quickly to see if that makes sense. I could actually keep this and say exit 1, and here I'm going to do a D instead of something else. And then see what that looks like. I have one value which is I got two, 162 and 161, and I think that's what it is. And 162 there is going to be the first letter, which is O. No, that doesn't make sense. I guess I'm looking at like every... Yeah, I'm not sure it makes sense. I'm writing the map. The map should only take 1 byte. Then I'm writing the... And 162 is... shouldn't be a problem. Then this is O, then this is P, then this is the number 1. Then 161 is the start of a string. Then I've got D, which is here. Then 129 is a map with only 1 value in it. Then I have 170. I'm writing a map, then I write a... So 170 is going to be the length, the string and the length. Then I've got R, P, C, V, E, R, S, I, O, N, and the number 1. So none of my actual string characters are like UTF-8 stuff. And also, I don't know why I did that, because I could have known that by just looking at the fact that when I use the official MessagePack try website, it yields the exact same. So that's really odd. Maybe I should try to send empty strings and see if it... let's try that. I keep thinking I should just go, but what I'm going to do is I'm going to say I'm going to start with this one and see if it starts invalid UTF-8. Invalid UTF-8. Now let's see if instead of doing this, I commented all of these out. Because the thing is, now I'm writing a map, so there shouldn't be no UTF-8, invalid UTF-8. Okay, so there is a problem in like the actual transport. Maybe it's even in WS send, because I'm just mem copying with no masking. Yeah, there's something odd, because when I set an empty object, it still say UTF-8 encoding issue, where I'm not doing any UTF-8. I don't have any strings. But yeah, anyways, good stream, some progress. I'm happy with what I did. See you, bye.